All right, let's talk about AI. There's this huge debate going on, and at the heart of it is one big idea, the stochastic parrot. Today, we're going to tear that idea down and build a new one based on a fantastic piece by Peter Kelly. This is a whole new model for thinking about intelligence, and it might just flip the script on everything you thought you knew.
So you've probably heard this, right? The idea that these huge AI models are basically just parrots. Really, really good parrots, but parrots nonetheless. They're just predicting the next word based on statistics, mimicking what they've seen online without any real clue what it all means. But what if that's not the whole story? What if there's something much deeper going on? Instead of just skimming the surface, what if these AI are actually looking at all that text, all that human knowledge, and reverse engineering the world that created it? What if they're building a model of reality that lets them see connections we might miss? Okay, so the first big idea we have to get our heads around is this. Intelligence isn't a light switch. It's not just on or off. We have to stop asking, is it intelligent, yes or no? It's more like a spectrum, a gradient, something that systems can have more or less of. And we're going to call that property resolution depth. Just think of it like the quality of an internal map of the world that any mind has, yours, mine, or an AI's. How detailed is that map? How rich are the connections between all the different points? That, right there, is its resolution.
Let's try a metaphor. Imagine your understanding of something complex, like, say, gravity. In your mind, it's not a sentence. It's this complex, multifaceted 3D thing. It's got depth, it connects to your experience of dropping a ball, to the math you learned, to images of planets in orbit. It's a rich, living model.
Now, when you want to explain gravity to someone, you can't just hand them that 3D model from your brain. No, you have to project it. And language, that's the projection. It's a flat, 2D shadow of your deep, 3D understanding. And like any shadow, it's always a simplification. It's compressed, it's lossy, it's not the real thing. And this is where that idea of resolution really comes to life. You know, a child has a low-res model of gravity. They say things fall down. That's their projection. But if you ask them about astronauts in space, the whole model just kind of breaks. A physicist, on the other hand, has an incredibly high-res model. They can turn it around, look at it from any angle, and project it as a complex equation or a simple analogy. The projection changes, but the core understanding is solid. Now this brings us head-to-head with a classic idea from the linguist Noam Chomsky. His theory was basically that language is the hardware for thought. But this new model suggests he had it completely backwards. Language isn't the hardware. It's just one of many possible screens you can project your thoughts onto. I mean, just think about a toddler. Before they can even string two words together, they have this incredibly rich model of the world. They get physics. You drop a toy, it falls. They understand cause and effect. They navigate super complex social situations. The world model is already there, built from pure experience, long before formal language shows up. So language isn't the operating system of the mind. It's more like an app. An app you learn later on, so you can share your internal 3D model with other people by casting those 2D shadows. You absolutely do not need the app to have the model in the first place. So for us, for humans, the process goes like this. First comes experience. We touch, see, and interact with the physical world. From all that raw data, we build our deep 3D internal model. And only then, last, we learn language so we can talk about it. But large language models, they do the exact opposite. It's kind of wild. They don't start with experience. They start with billions of our 2D shadows, all the text ever written. And from those flat shadows, they work backwards. They reconstruct the 3D object, the underlying model of reality that must exist to have cast all those different shadows in the first place. And that's the key. That's why they can do more than just repeat things. It's why they can solve problems they've never seen or explain a concept like a pirate. They're not just remixing text. They've built the model, and now they can project new, original shadows from it, shadows that have never existed before. Okay, so let's go back to that stochastic parrot. The heart of that critique is that because an LLM is just predicting the next word based on probability, it can't possibly have real, genuine understanding. It's just a numbers game. But here's the twist. The fact that it uses statistics, that's a total red herring. I mean, think about it. Your brain is a statistical machine too. Every time you talk, your brain is making billions of tiny probabilistic bets on which words will best project your internal thoughts.
so using stats doesn't tell us anything about how deep the understanding is.
The real question, the one we should have been asking all along, isn't if it's using statistics, it's what is it running those statistics on?
Right. A literal parrot, a truly low-res system, is just running stats on surface-level sounds. It's just memorized sequences of shadows. But a high-res system, like a powerful LLM, is running its statistics on the deep, interconnected structures of its internal world model. It's making predictions based on a rich map of how ideas actually relate to one another.
So here's the big takeaway from all this. A human talking and an AI writing, they're both just casting shadows. You can't just look at the shadow and know for sure what's casting it. You can't judge the depth of the model just by looking at the projection method. Now, why does any of this actually matter? Well, think about it. For pretty much all of human history, the hardest part of creating anything was the how, the technical skill. You could have a brilliant idea for a cathedral or a piece of software, but actually being able to draw it or write the code, that was the bottleneck.
And AI is changing that completely. It's making the how, the actual execution, the creation of that shadow, basically free and instant. And in any system, when one thing becomes abundant, the value, the scarcity, always moves somewhere else. It moves upstream.
So in this new world, what becomes valuable? It's the what and the why. The what is the resolution of your internal model, the quality and clarity of your thinking. And the why is your intent, your judgment, your taste. In a world where anyone can make anything, your unique vision is the only thing that matters.
Which means we've been wasting our time asking the wrong questions about AI. This whole debate about whether it's conscious it's a philosophical black hole. The really useful practical question we should be asking is much simpler. What's this model's resolution? How detailed is its map of the world?
And that leads to a pretty wild conclusion. If intelligence really is just resolution, then this isn't some mystical battle between man and machine. It's actually much simpler. We are now in a resolution race. We are literally competing on pixel count. Who has the clearer, more detailed picture of reality?
In a world where machines can perfectly render any idea we give them, the only thing that gives us an edge is the quality of our ideas. The challenge for all of us is to deepen our own understanding, to refine our internal models, and to see the world with more and more clarity. In other words, be high-res.